Hello, physics, electromagnetic induction, terminal velocity. The problem is the two resistance-less rails rest 30 centimeter apart on a 6-degree ramp. At the top, a copper bar of mass 40 gram is laid across the rails. Whole apparatus is immersed in a vertical 0.55 Tesla field. What is the terminal steady velocity of the bar as it slides frictionlessly down the rail? So is moving downward. So this is the two ramps, and there is a mass. So this is a mass, and it is moving downward. The angle is theta, which is theta is equal to 6.0 degrees, and this is mg, and this is normal force Fn, and this is the magnetic field B. So then uh, the magnetic, we have to find the terminal velocity. Velocity we have to find. So magnetic field will when it's a moving, which will produce EMF. So the EMF is the combination of length, magnetic field, and velocity, which will be mutually perpendicular. So EMF E is equal to the component of the velocity which is perpendicular to the magnetic field. So that will be equal to B L V perpendicular. So V perpendicular, this is V. So this is V, and this is at angle of theta. So this has a two component, and this is B. This is antiparallel, and this is perpendicular. This is V, and this is V cos of theta. So this is equal to V cos of theta. So E is equal to BLV cos of theta, equation 1. So the current will be equal to E by R, and E is this one, BLV cos theta by resistance. So that is current. So if we have current, then we can find out the magnetic field, magnetic force. Magnetic force is in this way. So this is mutually perpendicular to B. So FB is equal to IBL, as current is perpendicular to B. So this one, so from here I is this one, so FB is equal to I is BLV into cos of theta divided by R into BL. So this will be equal to B square, this B square, this is L square, B square, L square, V into cos of theta divided by R. This is the force. So Now it is the condition, this is equation 3. The mass is moving slide down, sliding downward. So, and net force 0, net force. So the forces are, this is FB. So this one, so this one, so this one is theta. This one is FB into cos of theta, and this one is theta. This is mg sine theta. Mg sine theta. So this force and this force. So this is negative. This is FB. So net force is equal to FB into cos of theta, this one, minus mg sine theta, sine of theta, this is equal to 0. So FB cos of theta is equal to mg sine of theta. FB is equation 3, so substitute this one. So FB is equal to B square L square V into cos of theta divided by R into cos of theta is equal to mg sine of theta. So V we have to find. So V on one side, V is equal to, this will go on the other side, R mg sine theta divided by B square L square into cos square theta. So substitute the values. So if you substitute the values, so this is V is equal to, if I write down R value is equal to 0.6 ohm, M is 40 gram, 10 power minus 3 kg, G 9.81 meter per second square. Sine of 6 degrees divided by B 0.55 Tesla whole square. L is a 32 centimeter, 10 power minus 2 meter square into cos of 6 degree whole square, and this answer will be 0.80 meter per second. This is the velocity downward. So this is the answer of this question. It is slightly complicated, but it is very interesting question. First, find out the EMF, and the velocity component should be perpendicular to B. V perpendicular to magnetic field. So this is a anti-parallel. This is a perpendicular. So E is equal to BLV cos theta, then divided by R, then we'll get current. And from this one, we will put this one, FB is equal to IBL I and L, B are perpendicular, so cos is 0, cos theta 0 is 1. So FB is I, we have found this one, we have found the FB. Now net force along going downward. So one is the FB force and then mg force. Those are balanced. Steady is balanced. So that's why it is 0. So then we find FB cos theta is equal to mg sine theta FB from equation 3 and find the value of terminal velocity. So this is the answer, the terminal steady velocity.